We're continuing with more example problems on radian measure. We're going to start by working some problems where we're given a trig function to evaluate with an angle in the trig function that's in radian measure instead of degree measure. And then after that, we're going to answer some word problems that involve applying your intuition of how much rotation a radian represents to real life situations. Okay, let's evaluate sine of pi over 3. Now, notice it doesn't say any units. If this was in degrees, like you couldn't, let's say we had sine of 30. What would this mean? Well, you would think sine of 30 degrees, but technically that's incorrect. Technically, someone would interpret this as 30 radians. If you mean degrees, you have to put degrees. If you mean radians, you don't have, you can put radians, but you could also just leave it unitless. So this is unitless, and so we interpret this as this is, they're asking, what is the sine of pi over 3 radians? Okay, so how do we evaluate this? Well, we can just go to the calculator, and we can toggle between radian and degree mode, go to radian mode, and input sine of pi over 3. That's fine. However, for the purposes of this course, since we're trying to understand trigonometry, let's go ahead and convert this to degrees and see if we have either a special angle or an angle that has a reference angle that's a special angle, and then we can evaluate the trig function manually. So pi over 3, so how do we convert pi over 3 radians to degrees? Well, we use a conversion factor. To convert any units, you use a conversion factor. Once you have a conversion factor, you're home free. It's easy. Okay, well, how do you get a conversion factor? You think about, okay, how many, so we're going from radians to degrees, how many radians are in 1 degree, or how many degrees are in 1 radian? Or if it's easier, how many, if I have a group of radians, then how many is that same group in degrees? And we know that if we have a group of 2 pi radians, that's a full revolution of radians, then that's the same thing as 360 degrees. So, okay, pi over 3 radians, we use the conversion factor, we say that there's 2 pi radians in every 360 degrees. The radians cancel, we're left with degrees. The pi's cancel. (180 divided by 3 is 60. So this is 60 degrees. So this is equivalent to, sine of pi over 3 is equivalent to sine of 60 degrees. What's sine of 60? Let's draw the reference 30, 60, 90 triangle. So this is 2, this is 1, this is root 3. Sine of 60, opposite of hypotenuse, that's root 3 over 2. Okay, sine of pi over 6, what is pi over 6? If it doesn't end up being a special angle or having a reference angle that's a special angle, then we'll just go to the calculator. So there's 2 pi radians for every 360 degrees. Radians cancel, we're left with degrees. The pi's cancel. 180 divided by 6 is 30. So this is the same thing as secant of 30 degrees. Let's come back to the previous problem. Secant of 30, secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse, so hypotenuse over adjacent. 2 over root 3. So 2 over root 3, let's rationalize this. 2 root 3 over 3. Okay, what is 5 pi over 3 in degrees? We can go ahead, since we're doing so many of these, let's go ahead and just do 180 radians, or no, 180 pi radians for every 180 degrees. 60 times 5 is 300 degrees. So we're looking for the tangent of 300 degrees. What is the reference angle of 300 degrees? So you go 270 and then 30. So the reference angle is going to be 60. Okay, so you've got a 30, 60, 90 triangle here. 2, 1, root 3. This is positive, this is negative. So tangent of the reference angle is opposite over adjacent. It's minus root 3. Okay, cosine of 3 pi. What is 3 pi in degrees? Well, we can actually do this in our heads. So 2 pi is a full rotation. And then now you're going another pi, that's another half rotation. So what's 360 plus 180? $540. This is 540 degrees. Okay, what is cosine of 540? That's coterminal with 180. So this is equal to the cosine of 180. This is a quadrantal angle. We know that's negative 1. Right, as we're coming in here, the adjacent's becoming equal to the radius, but it's in the negative direction, so it's negative 1. Okay, what is 7 pi or what is minus 7 pi over 6 in degrees? (180 divided by 6 is 30. Minus 30 times 7 is minus 210. Okay, what is the reference angle of minus 210? So minus 210, you go minus 90, minus 180, and then you go another 30 degrees. So the reference angle is positive 30. It's reference angles, no matter what, are always positive and acute. So, I mean, this is the angle we're talking about here. Minus 210. Okay, now 30, 60, 90 triangle, we've got, this is 1, 2, minus root 3. So now what is the sine? Okay, this is sine of minus 210. What is the sine of this reference angle? So we're not going to have to use the minus root 3. It's just going to be opposite of hypotenuse, so 1/2. Okay, through how many radians does the hour hand on a clock rotate in 24 hours and 4 hours? So these problems, I really like these problems because it's going to get you to start thinking about actual rotations in terms of radians. And so in reality, in my opinion, if you were asked this question in a real life situation, you would want to say this in degrees. We talked about why, even though radians are used a lot in theoretical science and math, etc., you're still going to use degrees for like actual geometrical visual representation type descriptions. Okay, but however, it's useful to go through these thought exercises where like you actually think about actual rotations that you might usually describe in degrees, but you think about what that would be in radians. It'll just help you to see your radians into your head. Okay, so 24 hours on a clock, okay, that's what? Well, that's 2 full rotations. Now, I'm not sure if they're asking, do we say, so, okay, 360 times 2 is 720, but I guess it's clockwise, so are they saying that it's negative 720? Probably not. So to me, that's 4 pi radians. I mean, if I was asked this question, how many degrees is 2 rotations of a clock, I wouldn't say negative 720 to somebody, right? It's more about what's the magnitude of the total rotation. 720 degrees. Well, in that case, that's 4 pi radians. Okay, what about 4 hours? Okay, so if a clock goes through a 4-hour rotation in anywhere, we can say, let's go from, so 12 to 4 is about here. Okay, how many radians is this? Well, okay, the hours are divided up. There's 12. It divides the clock up into 12 pieces. 1, 2, 3. That's 3 pieces. Then another 3. Then another 3. Then another 3. So at the 4 position, you've gone through 1, 2, 3, 4 of those rotations. So that's 4/12. That's 1/3. So you've gone 1/3 of a full rotation. So what's 1/3 of a full rotation in radians? Two pi over 3. Okay, through how many radians does the minute hand, so now they're asking us about the minute hand. Previously it was the hour hand. So the minute hand, how many rotations does the minute hand go through in 12 hours? Well, for every hour, the minute hand does a full rotation. So it's 12 full rotations. So what is 12 times 2 pi full rotations? That's 24 pi radians. We're about 3 hours. That's 3 full rotations. 3 times 2 pi, that's 6 pi. A space vehicle is orbiting Earth in a circular orbit. What radian measure corresponds to 2.5 orbits in 4/3 orbits? Well, think about what they're saying here. 2.5 orbits, 4/3 orbits. What's an orbit? That's a full rotation. So what is 2.5 full rotations in radians? That's 2.5 full rotations, 2.5 2 pi's. So 2.5 is, that's 5 halves. So 5 halves times 2 pi, that's 5 pi. 4/3 orbits. That's 8/3 pi. A stationary horse in a carousel makes 12 complete revolutions. Through what radian measure angle does the horse revolve? 12 revolutions. How many radians are in a revolution? 2 pi. There's 12 of those. 12 times 2 pi, 24 pi.